Hi everybody, this is the start of a Preparing for Methods course, which I'll put up on Connect for you, and there should be 5 or 6 sessions. We're going to start with Surds because that's a nice place to begin, and it's where Saddler starts. So the first part of Surds is understanding that if we have two surds multiplied together and has the same value under the surd, the answer will be the value under the surd. So what I mean by that is if you have root 2, for instance, times by root 2, the answer will be 2. If we have root a times by root a, the answer will be a. Quite a simple property to use and very useful. The second one we're going to look at is what happens if we're adding or subtracting two surds. So if I had 2 root 2 and I added 3 root 2, I would have 5 root 2. The very familiar collecting like terms property. If I had 2 root 2 plus 3 root 3, fix that up, take 4 root 2, that would equal 2 root 3s plus 3 root 3s is 5 root 3s, take 4 root 2s. Couldn't simplify any further because they're no longer like terms. And we could have root 12 equals root 3 times root 4. That's the third property over here. We can split the root 12 into two separate roots and multiply them together. Quite simple so far. Now, one form of simplification that we'll need to do later on is rationalizing the denominator, which means getting rid of the root symbol from the denominator. So if we had 2 on root 3, we could multiply that by a version of 1, in this case root 3 on root 3. Looking at the denominator here, we're trying to use this property to remove the root symbol, which we would now have done, and we end up with 2 root 3 on 3. Another common case that we have to do to rationalize the denominator is where the whole denominator is a radical, has a root symbol. So 2 on 1 plus a might be the expression we're trying to simplify. So I'm going to multiply that by root 1 plus a on root 1 plus a to again use this first property. So that will end up being 2 root 1 plus a on 1 plus a, simplified as required. The third case is a little bit similar. In 1 on 1 plus root 2, we're going to use a little quadratic property here, or property that we're first introduced to in quadratics last year. I'm going to multiply it in this case by 1 take root 2. Now the numerator is going to be simple, it's just going to be 1 take root 2. The denominator will multiply as per a quadratic, so 1 times 1 is 1, 1 times negative root 2 is negative root 2, root 2 times 1 is positive root 2. Now we'll see here that they're going to cancel out. And then root 2 times negative root 2 is negative 2. So that will be 1 take root 2 on negative 1, which would be root 2 take 1. Yeah, interesting little simplification there. Now, to simplify surds properly, we do need to know our square numbers. So there's a whole heap here. I'd specifically draw your attention to these ones: 169, 196, 225, 256. The relatively common ones that come up, so that you should know that the root of 225 is 15 and the root of 196 is 14. But in this case we've got some rather simple ones. Now, the trick to simplifying surds is to split them into square numbers and not square numbers. So in this case, root 8 can be split into a square number, root 4, and root 2, as per the first property up here. And we know that root 4 from here is actually 2, and thus we can simplify it to root 2. The same with root 27, it's root 9, which is the square number, and root 3, and 75, which is root 25, and 3, which gives us 3 root 3 plus 5 root 3, which is, by our second property, this one here, 8 root 3. Oops. Our third example is a rationalizing the denominator example. We want to remove the root symbol from the root 2, so we're going to multiply by root 2 on root 2, which is just 1. So it won't change the value of the fraction, but it will remove the radical symbol from the denominator. That gives us 3 root 2 on 2. And that pretty much finishes our little review of roots. Hopefully that's been a little bit helpful. Thanks everyone.